All right, 9-3 in advanced geometry. We're talking about golf and billiards today. The name of the game is putt-putt golf, and there's some rules here. I've got this ball. Balls are located on the tee, if you don't know anything about golf, you know. And in putt-putt, it's just sitting on the ground. It's not really on a tee. And I got to get the ball into the hole, but here's the problem. There is an obstacle in the way. I cannot hit this ball straight into the hole, and there are rules. I cannot let the ball leave the ground till I kind of shoot it over that. Like, that'd be awesome if I could do that, but that's against the rules. And I can't put any spin on the ball either. So our idea is that if we maybe like bounce it off of this wall, we could do that. And here's how you do it. You do it with reflections. So would you believe I would like to do this? The ball is on the tee. Yes? You know, so I'm starting on the tee. I need to hit it off of the wall and let it go into the hole. Are you cool with that idea? What I need to do is work backwards. This is where I'm trying to get. I'm going to like reflect the hole over the wall in that case. And how do you feel about it would go like right there if I reflected that? That's going to tell me where I need to aim at. I need to aim from this ball to that point right there. Problem, if I hit it, will it actually go to that spot or not? Yes or no? Will it actually go to that spot? No, because the wall's in the way. Are you with me on that? So what's going to happen is, if I did that, it's going to hit the wall at this thing called an angle of incidence, which is the first vocab word on your paper today. The angle of incidence, I don't have it up here to define. I'll just tell you what it is. It's the angle the ball hits the wall at. The angle the ball hits the wall at is called the angle of incidence. The angle the ball hits the wall at. Now, if we need to pause today's video because I'm going to kind of go pretty fast and you have to do all these reflections, please pause the video when you need to so you can get things done. But I'm just going to make this up at 30 degrees, right? You know, what if that was 30 degrees? Here's a fact, Jack. If the ground is flat and the wall is straight and we don't put any spin on the ball, the angle of incidence, like the angle the ball hit the wall at, it will also leave the wall at that exact same angle. So if it hits it at a 30 degrees, it is going to leave it at a 30 degrees. That is called the angle of reflection. That's the second vocab word of the day. The angle of reflection is the angle the ball leaves the wall at. The angle the ball leaves the wall at is the angle of reflection. And like I said, when you follow the rules of the game, if the ground you're on is flat, there's no hills, no curves, nothing like that. If you're on flat ground and the wall that you bounce off of is straight, you don't put any spin on it, the angle of incidence will always, always, always equal the angle of reflection. So we'll use that fact to do two little golf problems right here. I got an old slideshow. You have all these rules to do a golf problem typed out to the side in a little gray box in this one. So here's what we got to do. Draw a path from the tee to the hole with a bounce off wall X, then wall Y. They're going to tell you what to do on most of these homework problems. You follow their instructions. So the first step in there is always to write the path. Isn't that what I got in the box up there for you? So here's what we'll do. Where's the ball start? Hey, let's be careful. If you write the path in a weird location, it's going to get in the way of your reflections and all of that stuff, right? So I want to just try to stay out of the way, so I'm going to put it like right here. Hey, notice I put a capital T, because what is this T in this picture more like? More like a point or more like a line? More like a point, didn't I use a capital letter? Then, according to the instructions, where would I like the ball to go after that? They told me they wanted to hit what? Wall X. Is wall X more like a point or more like a line in this case? So I'm going to use a lowercase cursive letter. Then where would they like the ball to go? Hit wall Y. Again, it's more like a line. And they don't tell you this. Sometimes they do. But it should be common sense. Where would you like the ball to end up? Into the hole. Is the hole more like a point or more like a line? More like a point. So a capital letter. I grade the path, right? You must write the path down for me. So that's step one, write the path. Then we'll do reflections, and here's what we do. The reflections, we have to go backwards. This is the path from left to right. It starts with T. If I go backwards, don't I want to start from H in this case? You must draw these what I call swoops right here. Put this swoop right here, start at H, and please draw that arrow right there. Have to do it. It's part of your grade. What did I point to? A line or a point right here? A line. That means I need to do some reflections. What do I need to reflect? Wherever I had H, right? I need to reflect it over line Y. So here's our thing. Grab your geometer and extend out line Y very much longer, right? So nice and long. We're going to extend that bad boy out real long. And again, if you're in video land here and I'm moving too fast for you, hit the pause button, right? Get things done. Don't let me get too far ahead of you. The weird thing about the hole is it's this giant circle right here. So just like put a dot on the inside of it so we can reflect that guy. Sometimes the hole is a little too large. Please reflect it. Let's call that H, by the way, Let's reflect that over line Y. And if you guys would do me the pleasure of telling me how far away that is. So black line on top of the line, we extended out very much longer. Centimeters edge lined up with that. I don't have it all measured out because I blow up the screen too much. So for the benefit of the video audience so they know what they're doing, could you kind of tell me how many tick marks? Yeah, remember we'll be off a little from each other, about 2.8, 2.9-ish. Sound all right? So we'll reflect that over and call that H prime. Get that done for me. And like I said, if you got to pause the video, we'll pause. So we have done the path, right? And here's the thing. We put our little swoop. You got to keep swooping back until you get back to the T. So I'm going to go back to the path and swoop again. So I have reflected H over H prime. Let's swoop again and talk to me. What did you point to? Did you point to a line or did you point to a point? That means we have to do another reflection. But here's the trick, the thing that could make this whole thing go wrong for us. What should we reflect over line X? And the answer is the new point. We have put H prime into this picture. Isn't he the newest point in the picture, right? That is what you need to reflect over line X. So if you need to turn your paper, but extend out line X very much longer. And we will then reflect H prime over that line, right? So we're going to reflect H prime over it. So here he is, right here. Black line on top of this guy right here. He's going to be some ways away now, right? It's probably like some 40-some tick marks and everything, or 4. So let's see what that measures to be. How far is H prime away from that line? Remember, the line's got to be on X, right? Your black line's on top of line X. And then what is our votes for it? About 5.3. If we're not getting that, help a neighbor out. Pretty darn close to it. But here's the weird thing. What do you call it, right? You can't call it H prime. H double prime is what it's actually called. You put 2 apostrophes, right? So instead of prime prime, we'll call it H double prime. So mine, can you see, I put my path in a bad spot right here because I kind of did that on purpose. I told you at the beginning, watch out where you put it. He's kind of in the way. Oops. We'll get better at where we should put it as we start getting more experience with it. Are we okay with H double prime getting to be up there somewhere? Yes? Cool. Then what do I do after I do it? I go back to my path and swoop again. Let's swoop again and tell me, what did I point to? A point or a line? Point. You're done. We're out of lines. No more lines, right? We are done reflecting. So it is time to connect. And please let me do this first and then you follow my lead. We have to connect, and according to this, it says connect forwards. So you know how we just did this path backwards right here? We're going to connect forwards. That means we're starting here. Bing! Isn't T at the beginning? And we connect from T, don't do it yet, to the highest primed point. I want to make sure that doesn't mean the one that's closest to the top of your paper. That's not what the highest prime point means. It means the one with the most amount of primes on it. Doesn't H double prime have more primes than H single prime? So here's the thing. Watch this, because this is wrong. If I connect, I was trying to get that straight edge from here to here, that's not going to happen. There's no way that's going to happen. The ball isn't going to go to H double prime. Why isn't it going to go to H double prime? What's going to happen right here, man? It's going to hit the wall, and what should happen? It should bounce off of it. So when we connect, if you would connect like this, solid on the inside and dashed on the outside. What do I mean by inside and outside? The golf hole right here is just this green highlighted thing. So the ball is going to go to wall X, and it's going to bounce off of it, but we had to aim to where H double prime was. We had to aim where H double prime was. So now, here's the new thing. The ball has went so far. Let me just kind of do it in green. It went boop. Isn't it totally going to bounce off of that? Where it will mathematically go is because this angle of incidence right here is where it hit the wall at. It will bounce off at the same angle, and it'll go to H single prime. So connect from where the ball hit the wall at, right at that green dot, to H single prime, solid on the inside, dashed on the outside. And can you kind of tell that this angle, whatever it measures, is the exact same angle as that? Where it hit the wall was the angle of incidence. Where it left the wall was the angle of reflection. Those are the same. You don't need to put those arc marks. I'm just kind of showing you that's what happened. But then it did this. So it went boom, boom. Is it going to bounce off wall Y still? Where's it going to go? Into the hole, baby. So that's all solid. It's going to go in the hole. It's going to go in the hole. So the connecting thing is weird, right? That's why there's still only 2 examples today, but I won't turn you completely loose when I give you homework. I'm going to come check that you do the first 2 right before I really turn you loose. But we're still not done. There's a step 4. Doesn't step 4 say to draw arrows to say which way the ball is rolling? What that means is this. Didn't the ball start at the tee and it went that way? Right? Then it bounced off the wall and went that way. Then it bounced off the wall and went that way. Please put some arrows on your path to say which way the ball is rolling. And if you're watching in video land, I did do a physical example with the golf ball in the classroom. This totally works, man. The math behind this is perfect. This is a perfect scenario mathematically. But what gets in the way is physics. Would you believe it is physically hard to actually get the golf ball to go where you want to go? Because here's what we did. We mathematically figured out, after all of that, here's the ball. All you have to do is aim to that orange spot. If you aim to that orange spot and hit it, you will get this ball to go in if you can hit that one orange spot. But physically, that is not an easy task to do, right? For you guys in class today, I got lucky and got it on my first try. That very rarely ever happens because I am not a talented golfer. But there are people in the world who are really good at golf and can do that. If they measure things out and say, got to hit it right here, I'll do it, right? You know, that kind of stuff. So the other thing is, I might hit it there, but would you believe you also have to hit it hard enough to where it will actually do all the pattern and bounce it all out. So the math is perfect. The physics is real. The physics is the hard part about this. Does that kind of make sense? So that's miniature golf. Most people call it putt-putt golf. A lot of people accidentally call it miniature golf. The next thing is billiards. Have you ever heard of the word billiards before? Yeah, exactly what I thought people would say. They say that's pool. That's because time has passed us by. Billiards and pool are completely different games, but they're very much alike. Why is this table right here not a pool table? What is missing from this to make it a pool table? The holes in the table, which are called the pockets. Are you with me on that? Long time ago, when they invented the game, they didn't put pockets in the table. They just like put some balls on the table and there was no pockets, and they said, hey, I'm going to challenge you to a game of billiards. I've got ball V here and ball W. I can hit ball V into ball W by bouncing it off of 3 walls, right? You know, boom, boom, boom. It was just like, can I mathematically bounce it off so many walls and hit the other ball in that case? That's actually harder than you think. It's kind of challenging, and some dude later was like, hey, what if we like put holes in the table and tried to like hit the balls into the hole? And it's like, yeah, that's a much better game. You know, we'll call it pool instead of billiards. But there is billiards out there. It still exists where they don't have pockets on the table. They also have some games called snooker where you've got to hit this red ball before you can actually hit your ball. In that case, it's all kinds of cool stuff. But billiards is an old game. There are no pockets in the table. You just got to bounce it off some walls and make it hit another wall. So it's the same 4 steps as before. I put them down at the bottom of your screen. So it says draw a path that starts at ball W, bounces off C, B, and A in that order, and then hits ball V. So let's write the path. Where are we starting at? W, capital letter, because he is like a point. Then please draw the rest of this path. Where's it going to go? Next, then after that, and then after that, and where's the final destination? Please make all the walls, aka the lines, lowercase letters, and all of the points, like the pool ball, or the billiard balls, or the golf balls, and the holes, capital letters. Cool? And like I said, only 2 examples, so the better you can like kind of help me out with this, the faster we'll be done. I got my path done. It is time to do some swooping for reflections. Which way do you go? Forwards or backwards? Backwards. So 1 swoop at a time. We're going to take this and ba-ba-boom. So don't we need to reflect ball V over line A? So please extend out line A very much longer. And then we'll reflect ball V over line A. So it should go like over here-ish, right? And just for the benefit of the video audience, would you tell me how far that was on paper? 1.1-ish? Is that what we're hearing? Cool. And we'll call him what? What would you call that point? We reflected V over the line, so we'll call him V prime. Cool. And then it's still new, so people are like, okay, I got that. What do I do next? Every time you do a move, go back to the path and swoop, right? Go back to the path and swoop. So I'll swoop again, and I'll say, what did I get to? Did I swoop to a line, or did I swoop to a point? B is like a line. That means you got to reflect, right? We got to reflect over line B. So extend that dude out very much longer. It would be impossible to reflect V prime over B without extending it out longer, because B doesn't even line up with that perfectly, right? So you got to extend that guy out longer. And who are we reflecting? The newest point in the picture. You only use a point once, right? So we made V prime. Please reflect him over line B and call him V double prime. Turn your paper as you feel necessary. Make it easy on your brain. But the black line goes on top of this guy right here. Again, if you're in video land, but in class, and we're working on this because I'm not here tomorrow, help your neighbor out. You know, it's like, oh, put your line here. You know, do that. Help each other out. Be a buddy. But that's a long ways, right? What was it like? I'm just guessing from the past. Yeah, like pretty close to 6, right, is what I thought. So about 5.9. You also don't need to sit and count 59 little tick marks, right? Do you realize they're groups in tens, you know? So it's like, okay, here's 10, 20, 30, 40, 50, all that good stuff. Then go back to the path once you've done that and swoop again. I have swooped to C, which is like a line, so I must do a reflection. Extend out line C very much longer. And then this is where it starts getting tricky. You have to put your black line on top of the line you just extended out. Like it's supposed to be C. I remember a lot of times people accidentally put it over A again. It's like, no. We want to do it over line C. Right? So it can get weird. But it's a long, long ways. Make sure we're using the centimeters edge of our ruler and not the inches, because it's a little easier. Sometimes you might have to like just flip your paper 90 degrees all the way around because your line's like, man, I ain't got enough room to put my geometer on it. Go use the top half of your paper instead of the bottom half of your paper. But you call that V triple prime. V triple prime. V triple prime. And then once you got V triple prime, go back to the path and swoop again. And how do you know you're done reflecting? Because you ran out of lines. Right? I'm done with lines. I'm back to W. Cool. I'm going to give you a chance to do the first connection right. Just connect one thing together, the first move. Start forwards in the path, meaning here, and connect to the highest primed point. Solid on the inside, dashed on the outside. What do I mean by highest prime? The one with the most primes on it. Not this one because he's at the top of your paper. This one because he's a triple prime. He has the most amount of primes on it, the highest prime. So solid on the inside, dashed on the outside. Checked out with mine. Like I said, if I'm going too fast, pause the video and get things done. And here's what I'll tell you, years of experience. I would say all to this point is like 99% success rates. It's like, all right, I'm getting this. It's the next move. That is weird. So I'm going to do a couple. Let's see if you can tell me why this is not right. Please pretend solid on the inside, dashed on the outside. But are we up to this point so far, right? So what's wrong with this? Connecting those together. What's wrong with those? Yeah, this is not even inside the billiard table. Isn't the billiard table in orange in that case, right? So that's not cool. So it happens, though. Let's try it. What about this? Remember solid on. What's wrong with that? The ball's not there anymore. Isn't the ball like right here in this case? The ball has hit the wall, right? So that's the weird connection, is what am I supposed to do next? Connect from where the ball hit the wall at. Let me erase everything that I've got so far. From where the ball hit the wall at to the next highest prime point. Sorry about that. So go from that orange dot to V double prime. Solid on the inside, dashed on the outside. Got to go from where the ball hit the wall at. And then try your last move. I shouldn't say the last move, the next move. Try the next move after that. Where would it go? The ball has went boom, then boom, get him going to the next spot. But every time he's going to bounce off the wall. Where should he go? Towards what? B prime, right? So boom. And then don't forget the ending move is, of course, the ball's still not finished. We need the goal for it to hit ball V, right? You know, so it's going to bounce off the wall and do that. And that's where I would say you would get 3 out of 4 points for this. This actually might have more because there's 3 reflections, so I have to think of, there's probably like 5 points on this, like -1 still. Something's missing. The very last step gets forgotten a lot. We need arrows to show me which way the ball's rolling. So didn't he go from W to that wall, to that wall, to that wall? Don't forget your arrows. Cool? That's it, baby. But you're not free. What I'm going to have you do, obviously this is not for you in video land, so I'm going to end the video, but please, 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 in video land, here's the biggest mistake, not reflecting the new point. Once you move once, then you've got to use the new point to get another one. Don't keep using the same point over and over and over again. So let me know if you have any questions.